All right, we have three books, X, Y, and Z, on a table. The weight of each book is indicated. The force on Z, of Z on book Y is what? Well, I'm going to draw three free body diagrams, and I'm going to start with our free body diagram for object X. Now, object X is going to have two different forces on it. It's going to have a weight force, m sub x, this is 4 newtons, and I'm going to have an upward normal force. But I'm going to actually be very specific on my normal forces. This is the normal force on from Y on X. Block Y is pushing up on block X. Otherwise, block X would go falling through. Block X knows block Y is there because block Y pushes up on it. You can imagine that you can replace the book by your hand, block Y, and you'll see that the book Y, when it's your hand, you'll feel a force on it. So there is a normal force pointing up on our top book. On our middle book, on book Y, I will have a couple different forces. I'm going to draw a free body diagram for this. Pretty much like always, we have a weight force, my times g, and this is what's equal to 5 newtons. But I also know that book Z is pushing up on us, so Z on Y. I also know that book X is pushing down on Y. This book, if we put a scale here, we know that this book X is sitting on top of book Y. So there's also an additional downward force. It's a normal force of X on Y. And last but not least, let me get a different color out. Last but not least, there's our Z, our book Z. And this has, again, 3 forces acting on it. It's got a weight force, mzg, which is 10 newtons. It's got an upward normal force from the table on Z, and it's got a downward force of book Y on Z. So the table pushes up on the book above Z pushes down on it, and we have gravity, the earth, pulling the book down as well. So we go back, and now that we have our free body diagrams, we look and see, we want the force of book Z on Y. So we want Z on Y. It's this guy right here. We want Z on Y. All right, so how do we get Z on Y? Well, Z on Y, we know that if I assume up is positive X, that my Newton's second law for these guys, F equals ma, or our net force gives us an acceleration, and if this whole thing is not moving, our acceleration is 0. So it just says nz on Y minus myg minus nx on Y has to be equal to 0. Force up, downward force of weight, downward force of the book above it, gives us 0 acceleration. So all I have to do is solve for that value, and I'm done. Well, nz on Y is equal to myg plus the normal of x on y. Well, I don't know what this is, but I do know that I have this is nx on y. I know I have ny on x. And ny on x minus nx, or mg, my weight force, is going to be giving me 0 because of Newton's second law for this problem. So ny on x is equal to mxg, which is just equal to 4 newtons, because that's what mxg is. But I remember Newton's third law, and Newton's third law says that if book X is pushing on Y, then Y is pushing back on X exactly the same strength. Or Fx on Y is equal to Fy on X, and their magnitude. We know that they push in opposite directions and they push on opposite objects. One pushes on Y, one pushes on X, but they're equal in magnitude. So this Ny on X is the same as Nx on Y. So I'm just going to rewrite this equation. Nz on Y is equal to myg. Well, myg is just 5 newtons plus the 4 newtons from over here. So I can see that Nz on Y is equal to 9 newtons. And this makes sense. We're looking for the force between those two, the force that Z is pushing on Y. Well, we know that the total weight above it is 9 newtons of weight. So that means in order for this to not move, this kind of combined double book thing, imagine that they're stuck together with tape, that this whole book is 9 newtons down. If it's 9 newtons down, it has to have 9 newtons up to give it an equilibrium. So this is the explicit way to solve it. I didn't even need the third free body diagram. It didn't ask me about any interactions on Z, just how Z interacts with Y. So again, nice simple free body diagrams, one coordinate system, which was nice in this problem, but we are just very careful to make sure that we did everything and labeled all of our normal forces one object acting on another object.